right, so 6.1 notes. We're going to talk about the law of sines. So here we have oblique triangles. Oblique just means that they're not right triangles. And we're going to be solving them, finding all of the angles and all of the sides. So typically if we had a right triangle, we would use Pythagorean theorem to find the angles. Pythagorean theorem to find the sides. To find the angles, we would use SOHCAHTOA. But here we can't because it's not a right triangle. So we have another formula that we could use. Capital letters are going to note the angles. Lowercase letters are going to note the sides. So when you see a lowercase letter, it's talking about the side of the triangle. If you see a capital letter, it's talking about the angle. So make sure you pay attention to the difference. One other thing that we have to keep in mind, you can draw, it's not going to give you a triangle every single time. You can draw it. The angle, so capital C, is going to be opposite of lowercase c, so side C. Capital A, angle A, is going to be opposite of side A. And then angle B is going to be opposite of side B. So it's not going to give you a triangle every single time. It might just give you 3 pieces of information. You have to find the other 3, but you can draw your triangle if you want to. Just keep this in mind. So to solve an oblique triangle, you need to know the measure of at least one side and the measure of any 2 other parts of the triangle. 2 sides, 2 angles, or 1 angle on one side. So we could have angle, angle, side, angle, 2 sides, and an opposite angle, side, side, angle, side, 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 or side, angle, side. These are the different cases that we have. It's not really important that you know which one's which, but we are going to talk about the ambiguous case in the 6.1 notes, which is when we have 2 sides and an opposite angle. So if you have side, side, angle, here we're going to have to check for 2 triangles. Which we'll talk more about this. So our formula for law of sines is this here. So side A over sine of the angle A would be equal to side B over sine of the angle B, which is equal to side C over sine of the angle C. So you don't have to set it up as 3 parts of your equation here. It's just each pair makes a proportion. So you really are just setting one equal to the other. You can only solve for one variable at a time, so you always want to start with whatever pair you have. If you have side A and angle A, you want to set that up as part of your proportion. Then you can set it equal to the other one to find whatever else you need. Since it's a proportion, it doesn't matter if the sides are on top or if they're on the bottom. If you wanted to say sine of A over A is equal to sine of B over B, you could do it this way too, as long as you are consistent. If the sides are on the top, make sure you keep it on the top. If the sides are on the bottom, make sure you keep it on the bottom. So you need to be consistent. Remember, lowercase letters are the sides, capital letters are the angles. So it says it on the next page. The law of sines can also be written in reciprocal form. Just make sure you're consistent with it. If you put the sign on the top, keep it on the top. So let's look at example 1. So for the triangle shown, it gives us angle C is 102.3, B is 28.7, and side B is 27.4 feet. It draws the triangle for us, so that's good. So we can use this to find our other 3 missing pieces of information. We need to find angle A, side C, and side A. We can use our law of sines to find all of our missing information here, but even easier than using law of sines to find our missing angle, since we have 2 angles of our triangle, we can easily find the third. What do we know that all 3 angles of a triangle are going to add up to? 180. So we know that all 3 angles add up to 180 degrees. So I can take 180 and subtract the 2 angles that I have. So we can do 180 minus 102.3, and then minus 28.7. So we can plug that into our calculator. We get 49. So angle A is 49 degrees. So I'm going to write that here. Angle A is 49 degrees. We also need to find side A and side C. Any questions on how we just found angle A? Perfect. Doesn't matter which one we find next. We're going to have to find both of them. So we can find A first. I always want to start with a pair of side and angles that we have. So if I have side A and angle A, I want to start that as my proportion. But I don't have side A. I have side B and angle B. So I'm going to start side B and angle B as my proportion. So always start with the pair that you have. So I'm going to say sine of B, which is 28.7, over side B, which is 27.4. Now I can set this equal to, which one do you want to solve for first, A or C? We'll find A first. Doesn't really matter. We can find A. So sine of the angle, which is 49, over the side A. So if you put your signs on top, make sure it's on top for both fractions here. Now when we solve for A, we can cross multiply. So we have A times sine of 28.7 is equal to 27.4 times sine of 49. Then to get A all by itself, I can divide both sides by sine of 28.7. So A is going to be equal to this. I'm putting this into the calculator. If you put it all in the calculator at once, make sure you use parentheses. If you multiply the top, use parentheses. I would multiply the top, push equals, get a number for the top, and then just divide that by the sign of the denominator. So make sure you know how to use your calculator. So in my calculator, I'm going to do 27.4 times the sine of 49. I'm going to click equals, and then I'm going to divide that number by the sine of 28.7. So for side A, we get 43.06. It'll typically say how many decimal places it wants you to round it to. We can leave it as 2 decimal places here. So we have 43.06. What unit are we talking about? How long? 43 what? Feet. Awesome. B was given and it uses feet. So we have to make sure we include feet in our answer. Don't forget the unit. If you're talking about the angle, you need to put degrees. If you're talking about the side, use whatever unit it gives you. Next, we want to find side C. So we have to set up a proportion again. So we're going to use the law of sines again. Since B was given to me, I'm going to keep using that same proportion to find C. So I have sine of 28.7 over 27.4 is equal to, now sine of C over C. So sine, bless you, sine of 102.3 over C. Any questions on how we got that proportion? So this is sine of B over B is equal to sine of C over C. So now we just want to solve for C. So same thing we did in the last one, we want to cross multiply. So C times sine of 28.7 is equal to 27.4 times sine of 102.3. And then we can divide both sides by sine of 28.7. So C is equal to, then we're going to put this into our calculator. So I'm going to find the top. I'm going to do 27.4 times sine of 102.3. Push equals, get a number, we get 26.77. And I'm going to divide that by sine of 28.7. So C is 55.74. $55.74 what? Feet. Actually, it should be 0.75 because it rounds up. It's 0.75 feet. So these were the 3 missing pieces of information that we needed to find. So every question is going to give you 3 things. We have to find the other 3. So it's not always going to give you 2 angles and a side. It could give you different things. Bless you. One thing that's kind of helpful when you come up with your answer is that the smallest side is going to go with the smallest angle. The largest side is going to go with the largest angle. So looking at our answers here and the triangle that we have, what's our smallest angle that we have? A, B, or C? B. 28.7 is the smallest angle, so that's going to go with the smallest side, which was 27. Smaller than these 2. What's our largest angle that we have here? C, 102.3, which goes with the largest side. So that's kind of one way you can check your work to see if you did it right. All right, 6.1 part 2. We're going to talk about the ambiguous case. So if we have 2 sides and an angle, we always want to check for 2 triangles. So it could happen where we have no triangle. We could have 1 triangle, or we could have 2 triangles. So we always just want to check for 2 triangles, and then we'll figure out if we have just 1 or not. So I'll show you what to do in that case with the examples. But could have no triangle, could have 1, you could have 2. So in example 2, we're going to do the same thing. So it says a pole tilts towards the sun at an 8-degree angle from the vertical, and it casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? So here it gives us a picture, draws everything for us. So it's not a right triangle. What would the angle down here be? What is angle B? It's 90 plus a little bit more. How much more? 8 degrees more than 90. So what would it be? 98. So it gives us angle B, angle A. How can we find angle C? Awesome. 180 minus angle A and angle B. So we can do 180 minus 98 minus 43. Let's just plug that into our calculator. So we get 39. 39 what? Degrees. So angle C is 39 degrees. Now we're missing side A and side B. So we always want to start our proportion with the 2 known things that we have, with the pair that we have. So what do I have a pair of? A, B, or C? C. We have angle C and side C. So I'm going to start my proportion with C. So I'm going to say the sine of 39, so sine of the angle over the side, 22, is equal to, we can find A first. So sine of, what's angle A? 43 over A. Now when we solve, we're going to do the same thing we did in the last question. We cross multiply. So A times sine of 39 is equal to 22 times sine of 43. And divide by sine of 39. (22) times the sine of 43 would be 15.00. Then we're going to divide that by the sine of 39. So A is 23.8 23.84 what? Feet. We're talking about feet here. Next, let's find B. We can use A's as a proportion, but I would always just use what was given to you. Just in case A, we made a mistake in our math somewhere, we found the wrong answer, use the proportion that's given, because you don't want to use the wrong answer to then find the third thing. So since C was given to us, we're going to use C as our proportion to find B as well. So sine of C, which is 39, over side C, which is 22, is equal to sine of B. What's angle B? 98, over side B, which is just B. So we're going to cross multiply. So B times sine of 39 is equal to 22 times sine of 98. And then we're going to divide that by sine of 39, get the B all by itself. And then we plug it into our calculator. So 22 times sine of 98 equals, divided by sine of 39. What do we get? Awesome, 34.62. So 34.62 what? Feet. Perfect. So these were the three missing pieces of information that we needed to find. This page kind of just describes what it looks like for the ambiguous case if we're given two sides and an angle. It could happen where the sides just aren't long enough, so we have no triangle. Could have two triangles. So we are going to do some examples. So in example 3, we're given two sides and an angle. So since this is side-side angle, we need to check for two triangles. What would I do first? Find angle B. Perfect. So let's set up a proportion with what's given, the A's. So we have sine of 42 over 22 is equal to sine of B over 12. Cross multiply and divide. So 12 times sine of 42 is equal to 22 times sine of B. Divide both sides by 22. Put it in our calculator. So 12 times sine of 42 divided by 22 gives us 0.36498. It keeps going, but we're going to leave it in the calculator. This is equal to sine of B. How would I find what angle B is? Do the inverse sign. Sine negative 1. So second sign, second answer in my calculator. So this gives us B is equal to 21.4. So because I didn't get an error in this step, I know that I'm going to have at least one triangle. So I'm going to draw my chart here. Triangle 1, triangle 2. We always want to check for two triangles. So angle A was given, that was 42 degrees. So that's going to be the same in triangle 2. Angle A is 42 degrees. What did I find first? Angle B was 21.4 degrees. What's angle C? Oh, we don't know C yet. And then A and B were given to us. A is 22 and B is 12. We still have to find C. So let's finish finding everything for triangle 1, then we'll figure out if we have triangle 2 or not. How would I find angle C? Add the two angles and subtract from 180, or you could do 180 minus 42 minus 21.4. We get 116.6. So we would do 180 minus 42 minus 21.4. How would we find side C? Set up a proportion. So we're going to use the given proportion, so sine of 42 over 22, since the a's were given from the start. And then since we're finding C, we want to set it equal to sine of C, so sine of 116.6 over C. Cross multiply and divide. C times sine of 42 is equal to 22 times sine of 116.6. Divide both sides by sine of 42. Then put this in the calculator. So 22 times sine of 116.6. Divide it by sine of 42. Should get 29.4 in the calculator. 29.4 what? Inches. So all of these are inches. Don't forget your units for everything. Next, let's see if we have a second triangle. What would I do to find the second triangle?
180 minus angle B.
Awesome. Angle B was the first thing that we found. So I want to do 180 minus angle B. 180 minus 21.4. So 180 minus 21.4. That gives us 158.6. So always do 180 minus the first thing that you found. Now how would I find triangle 2 angle C?
Set a proportion. No, we can add the 180 minus the product.
Add them and subtract them from 180. So when I add these two together, what do we get? 200.6. Is it possible for me to have a triangle when two angles add to 200.6? No, they add up to more than 180, so it's not possible to have an angle C. So what does that mean? There's just one triangle. So we don't have a second triangle. It's just one triangle as our answer. Any questions? So if your two angles add up to more than 180, you don't have a second triangle. One more thing for the homework. There's a question number 11. It gives you degrees and seconds. You'll see it kind of looks funky. Like it'll give you angle A is 75 degrees and 11 seconds. It'll say something like this. Skip number 11. So you'll kind of see how the question, the degrees is a little bit funky. Just skip 11. Don't worry about it. I'll be nice when I look at the grade. Skip number 11. So in example 4, we're given two sides and an angle. So we have to check for two triangles. So just make a little note. If you're given two sides and an angle, you want to check. So we want to start with the pair. We have angle A and side A. So that's going to be the proportion that we start with. Sine of the angle, so sine of 85 over 15 is equal to sine of B over 25. So we can cross multiply. We want to get B all by itself. So 25 times sine of 85 is equal to 15 times sine of B. And divide both sides by 15. Then we can put this into our calculator. So 25 times sine of 85 equals, and then divide it by 15. So we get 1.66032. It keeps going, but I'm going to leave it in the calculator. Is this my angle? No. What's the last step that I need to do to find the angle? Do the inverse sine. Perfect. So I'm going to do sine -1 of this answer. So I'm going to click second sine button in my calculator. And then second answer to just copy that answer over. What does it tell you when you put that in the calculator? It says error. So it tells you error in the calculator. This means if you get this, then we have no triangle. If you end up with no triangle, you don't have to test for two triangles. That's it. We have no triangle. We're done. So here we need to check to see if we have two triangles because it gives us two sides and an angle. So let's start with the proportion that we have. We're going to do sine of the angle, so 20.5 over A, because we're given a pair of A's, is equal to sine of B over side B, which is 31. Cross multiply and divide. So this would be 31 times sine of 20.5 is equal to 12 times sine of B. And divide by 12. So this cancels. Let's put it in our calculator. So 31 times sine of 20.5 equals, and then divide that by 12. So we get 0.9047. It keeps going, but I'm going to leave it in the calculator because this is equal to sine of B. Is this our angle? No. How do we find the angle? Take the inverse sine. So sine -1 button. So when you do the inverse sine of this answer, you should get 64.78. We'll call it 64.8. So that is our angle B, 64.8 degrees. So because we have the possibility of having two triangles, I'm going to draw a little chart here so we can keep everything straight. What I found now is in triangle 1. I'll draw triangle 2 here. Start with the given. What were we given? What angle? Angle A was 20.5 degrees. We just found angle B, which was 64.8 degrees. We still have to find angle C, and then our sides A, B, and C. One second. A is 12, and B is 31. All right, so we found two of our angles. How could we find C? Awesome. We can add them and subtract from 180, or we could do 180 minus 20.5 minus 64.8. So let's put it in our calculator. So 180 minus 20.5 minus 64.8. Should get 94.7. So C would be 94.7 degrees. Now let's just finish finding everything for triangle 1. How would I find side C? Not Pythagorean theorem. Pythagorean theorem only works if this was a right triangle, but it's not a right triangle. So when we put this in the calculator, we get 12 times sine of 44.3 divided by sine of 20.5. You should get 23.9. 23.9 what? Meters. Awesome. So we have two triangles here. So this is our answer. So again, the important thing here to check for two triangles, you want to do 180 minus the first angle that you find. That's going to be the new angle in your second triangle. And then you solve the rest of it the same way that you solved the first triangle. So to find the area of an oblique triangle, we're used to our typical angle of a area of a triangle formula is 1/2 base times height. It's not always just going to give you the base and the height. If you had something like A, or this one here, where it's an obtuse angle, you can't just use the base and the height. So we have a formula to help us find the area. So on the next page, depending on what you have, so it'll probably give you two sides and the angle. So it's not going to give you the pair, like side A and angle A. It'll give you the missing one. So depending on what you have, you can use any one of these three formulas. So it's 1/2 side B times side C times sine of angle A. Or it's 1/2 A times B times sine of C. Or it's 1/2 A times C times sine of B. So notice how it's the two sides times the third side's angle. So these are three different formulas that you can use. It's the same thing, it just depends on what it gives you. So here it gives us side A, side B, and angle C. So it's perfect. It's everything we need. So our angle is going to be 1/2 A times B times sine of C. So our area is 1/2 times 90 times 52 times sine of 102. And we can plug this all into the calculator. So if you want to, you can multiply 90 times 52 times sine of 102 and then divide that by 2, or you can just do 90 times 0.5 instead of 1/2. Just make sure you know how to use your calculator. I'm going to do 90 or 0.5 times 90 times 52. You can plug it all in at once if you want, times the sine of 102. So we should get 2,288.87. Now here, what unit are we talking about? Awesome, meters squared. Since it's area, it's your unit squared. So it's just 1/2 times the two sides and the included angle, so the angle that's in between them. Any questions?